welcome back to the list. We have some components sitting here on the table. This is for the pool filling valve. Okay, so this is a solenoid valve. It uses an electromagnetic coil to engage and disengage the valve mechanism, which is located inside. This one happens to be 120 volt. They make them in all different voltages. They make AC, DC. This one's 3/4 inch MPT. And it may sound like overkill for a garden hose, but it's cheaper to buy a larger standard solenoid valve than it is to buy a normal size full port solenoid valve. So a full port solenoid valve has a valve mechanism which does not restrict the flow for the given pipe size it's designed for. A standard solenoid valve will restrict the flow even down to like 50%, compared to the pipe size it's designed for. So, to attach this to the garden hose spigot, I salvaged these old fittings here, which happen to be 3/4 inch. They go to a hose nipple. Those are going to go on there with, of course, some clamps. I got the male and the female. The other thing we need is a way to turn on and turn off the solenoid valve. So we got a relay. This is what they call an ice cube relay, because it kind of looks like an ice cube. It has a series of little tabs on the bottom. Those are the connections. You can just solder to them. It's really not advised, but you can. You could also jam on some little spade, female spade terminal connections. They're not the exact right size, but it will work. But this is the way they're meant to be used, and this is a socket, a relay socket. So it has the exact same pin configuration as the relay, and it just plugs in. So if you happen to burn out the relay, you just pop the old one out, pop a new one in, and you're good to go. And on the base, it has screw terminals, which makes it really easy to connect the wires. Now, this base also has the DIN connection, which snaps onto DIN rail. This one's a little tight. Wow, maybe a screwdriver for that. No, there it is. Okay. So yeah, that snaps onto DIN rail. And the DIN rail has these little slots, so you can screw the DIN rail up anywhere, like on a wall or on the inside of a cabinet, or wherever you happen to need the device. So that's the relay. That's going to turn on and turn off power to the valve. Yeah, it's warm in here. So I'm going to put all the electronics inside the house, and then I'm going to route just the wires that I need outside of the house. So the valve will be outside. That means I need to run 120 volts through. I happen to have a little, it's almost like a window, but it used to be a chimney exit for the furnace, but they ended up moving it to a different wall because it wasn't in the right spot or something like that. Anyways, that's covered with a piece of Lexan right now. So I'm going to use that to my advantage, and I'm going to attach one of these waterproof connections with some round cable, and this has a little rubber sleeve inside, and the more you tighten it, the sleeve compresses around the cable, creating a watertight seal. So that will be my bulkhead connection for the 120 volts. Alright, to control the whole thing, I have here a PLC, which is a programmable logic controller. It has a little chip on the board right here, and that's basically the brain. The rest is all just ways of connecting to that chip. Over here I've mounted some relays. This was for an old project. It has 4 relays. I don't need all the relays, I only need 1, but that's alright because I haven't used it in like, I don't know, 8 years. So finally going to be putting it to use. I soldered on some screw down terminals that connect to the relays. I soldered in the control wires for attaching the switching. So one set of these wires is going to read the float switch, and then my programming, which is kind of like a basic language. My programming will look for that float switch to be either on or off, and depending on how I program it, I can create a delay, I can have it go on for a certain number of hours, whatever. I can do it however I want to do it. More than likely I'm going to have it read to see if the float switch is too low, which would mean the water's too low. That would in turn turn on the water. And then I would put a delay, probably, I don't know, maybe a half-hour delay before it starts to look for the switch signal again. That way, if somebody jumps in the pool and the water's, waving around and hitting the switch over and over again, you don't have the water going on and off and on and off and on and off and on and off. So it's kind of like a what do they call it? A debounce code, like you put in a keyboard or any switch. So yeah, it opens the valve, waits at least a half an hour before it reads the switch again, and then it searches for the switch. And when it sees that the switch is then tripped, which means the water level has come up high enough, then it'll shut the water off. And again, I'll put a delay in the other direction so that once it sees that the water is high enough, it won't turn on again for a minimum amount of time. I don't know, half hour, 15 minutes, whatever. I can play around with it and keep changing it as I deem fit. So yeah, that's the programmable logic control. It runs on low voltage, 9 to 12. I'll be using a simple wall wart, which, yeah, it's 12 volt wall wart, but they usually put out a slightly higher voltage, like 13 or so, but that's fine because these boards have a built-in voltage regulator, so it can easily handle a couple of volts over, no problem at all. Yeah, so that's that. And that's everything on the table. I don't think there's anything else we need to put this together, other than putting it together.